The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, just want to make sure everyone can hear me. You can type here in the chat bar if you can hear me. And I also wanted to add, we'll wait another minute or two, but let's save questions for the last 15 minutes. I've established that time for us to, do a thematic sort of review of everything that I'm talking about. And yeah, just let me know if you can hear me and if you can see my screen. I also want to give you guys, a face to a voice. So I'm just going to share my webcam and say hi. How's it going, everybody? This is me. My name's Georgie, and I will be conducting this webinar today on generative design. I'm super excited about this topic. Awesome. All right, so everybody can hear me. This is great. I will get started. First off, I'd just like to say that, give you a little introduction to Microdesk. We've been around since 1994, and we have multiple locations throughout the U.S. and the East Coast, West Coast, and the Midwest. We also have an office in London and some other satellite offices in other areas of the world. We have highly skilled group of professionals working for us in the many disciplines of the AECO industry. Our approach is to reduce pollution in the world through better workflows and collaboration and thinking about how we use technology in the built environment, because we know buildings cause most of the pollution in the world. What do? We offer services in design, construction, operations, anything from BIM to owner representation to MEP. Please reach out to us. Here are some of our services. These are some of our leading partners. We're a platinum partner with Autodesk. And this is me. So I will be your presenter today. My name is Georgie Shkurti. You guys can call me G if you want, for short. About 10 years of experience in all the different fields of the building industry. I am specifically software agnostic. I believe that we can use all the different tools to help us achieve the goals that we want. Lately, I've been getting into data science and artificial intelligence. This is something that I feel like is going to hit our field really heavy. I think this presentation will be a precursor to more presentations in that vein. So let's talk a little bit about today's agenda. First, let's talk about the myth of generative design, because it has become a buzzword, and I'd like to demystify it a little bit, or at least give each individual their perspective on how they would like to use it. We'll go over a history of generative tools, where they were 10 years ago to where they've arrived today. We'll talk about Grasshopper and evolutionary engines. We'll talk about Rhino Inside Revit with Grasshopper, and then we'll talk about Project Refinery, Revit 2021, Generative Design, and all the plugins that have now arrived on the Autodesk platforms. But also we'll get into the cross-pollination, because I feel like this is where things are starting to get interesting, and how we used to think about things, and then there was a barrier of translation, whereas now we have these tools and we're starting to actually utilize them for time savings. I really like this slide because I've been playing around with these tools for many years now, and you always seem to find a definition of what generative design means to a different environment. For example, the middle one is from Autodesk's website, which defines it as an exploration process. They're thinking about parameters, they're thinking about materials and manufacturing methods. So they're talking about, the actual built environment, but in the sense of industrial design as well. I really like this definition of generative design in that this comes from, and I'm just going to pull up my screen here real quick. I highly recommend everyone go check out this website, the Generative Design Primer, established by Autodesk for their Generative Design plugin in Revit. But this is where I got that definition, which I kind of like, but we're still gonna go further into it, which is you may have encountered the term generative design in the context of producing design permutations, creating geometry from simple inputs, or even just building computational graphs using Dynamo and Grasshopper. It's nice, short, and succinct, rather than an iterative design process that involves programming to generate a number of different outputs. Now, there are also a lot of these buzzwords at the bottom: computer animated. These have been around since the 80s, genetic algorithms, and they are used in Grasshopper and Dynamo. I just want to sort of establish the lexicon of where these things come from before getting into how the tools are used. And I also feel that a lot of these do happen inside of the Dynamo Grasshopper environment, but the way that they're used is not fundamentally based in the architecture world or the built world. So we have to consider that. So this is how I would like us to look at generative design. I want to start from the parametric approach, which has been embedded into the BIM environment, and then move to the computational approach, which is essentially a system with the parametric family, if you will, or parametric model embedded into it so that it can be manipulated. And then the generative is essentially the combination of these two, where you are able to have a recursive development, which means that you can have multiple permutations where these two things change inside of each other. These three definitions I got from a white paper by David Stauswick. I highly recommend everyone read it, because this will also help in the sort of trajectory of how you want to use these tools. So let's talk about parametric. Just want to go over a quick little video as we built up to get to the generative. So what I'm doing here is I'm basically placing a window family into a wall. Now, a window family, this is where the information inside the family is parametric, where you can stretch it, move it, but there's also parameters that are text parameters and asset parameters that the window has embedded into it. So here we're talking about the heights, and so this is what we mean by parametric, right? Just a very simple example of a window. And then it's also got the types. Now, the one caveat to it being parametric is that the human still has to change the types and input the information. Whereas next, we're going to talk about computational. What does computational mean? So here I got a little Dynamo script, and I'm just talking about the idea of mapping an image to a curtain wall. This was something that was quite in trend back in the day, where had a lot of architects doing faces and images and things like that built into curtain walls. So I'm just going to quickly change this wall and place a gradient map as an image while using the curtain panels inside of it to change it. And that didn't go too well. Let me rewind that real quick. So this, I would say, is computational design in its sort of infancy, but essentially a Revit curtain wall is a form of computational design where you've got a panel mapped inside of a system, and then that system is able to change. Now with Dynamo, you have the ability to add more constraints to it and change the sizing of these holes and so on. And so this is where you enter, in the visual scripting language, you enter the computational side of things. Let me know if the videos are chopping up on you guys, because I will rewind them and play them again. So let's move on. Okay, so what we're looking at here is, back in the day, this used to be called Project Fractals. I was beta testing this for similar sort of studies. What they're doing here, they're just doing max height volume against surface area kind of challenge. This has now been adapted from Refinery into a Dynamo script. But what I want to talk about here is, obviously these parameters have constraints, and what we're using the Dynamo script here for is to input it into a generative design engine, which is built into Revit and Dynamo now, and you can see that up here. The other thing that I want to talk about is that I know these seem pre-made, but one has to consider the problems that they're trying to solve. Revit does have some pre-baked ones similar to Dynamo Player of things that we want to solve for, but like every project that we work on, the environment does tend to change the constraints that we're looking for. So here I've basically sent that script into the generative design engine that's built into Revit. And now I'm filtering out all my different sort of solutions for what I'm looking for. And let's say I want my heights for box 2 to be, 160 to 180, and my heights for box 3 to be, 20, and so on. These are obviously defined by zoning parameters, clients, and urban planning. Obviously, you could take this to the next level and also add sun analysis through Ladybug if you wanted to generate even more sort of constraints in how you're thinking about this. And here I'm looking at the different ways you can filter the different options. I'm using, I want to be clear here that I'm using very sort of simple ideas, but I want to highlight a sort of an overview or an aerial view of where the tools come from and how they've evolved over time. I foresee Microdesk doing many more sort of specific webinars on each one of these topics. Okay, so where did things begin? A crazy room of mad scientists that worked inside of an open source software called Grasshopper. I'm just kidding. But really, it did start with Grasshopper. Grasshopper was the first visual programming language that eventually sort of inspired Dynamo. Grasshopper was open source, and what we're looking at here is sort of the evolution the evolution of evolutionary engines that you can grab in Food for Rhino. So these essentially are plugins used inside of Grasshopper to generate different evolutionary solutions per problem that you're trying to solve for. These are the top 4 that I think are powerful, actually useful, and can get you to the results that you need. The bottom 3 are a little bit hard on the learning curve, whereas Galapagos is somewhat intuitive with a bit of a learning curve. Like anything else, we're talking about genomes and evolutionary engines. You have to have an idea of how you want to solve your problems. So this is on the NURBS modeling application end, which is Rhino. Now let's talk about the Revit side of things, where we've got, our building information modeling software. This is essentially the most important part of everything here, because this is where you can document all your generative design solutions. What we're looking at here is a graph of the becoming a Project Refinery Dynamo Studio into Autodesk Revit 2021. So Project Refinery worked in tandem with Dynamo or with Dynamo Studio as a standalone beta project for how to implement generative design and how to use it in a real sort of project environment. Eventually, these two were combined into Autodesk Revit 2021, and now you can just access them directly from the application. Dynamo is still there, so what I just showed in that refinery script was how you would use it inside of Dynamo. And now the Pandora's box of what's possible. I'm really excited about this because, one, we are able to go back and forth between Rhino inside of Revit using the Rhino Inside plugin, but also because we can generate both with Grasshopper or with Dynamo into Revit. So we can check ourselves and check how the two different generative design, or as some would say with Grasshopper and Galapagos and the other evolutionary softwares, procedural programming works. Now, what's really cool about this is that with Rhino Inside, you can essentially natively park the information into Revit and use it for documentation. I'll go over an example. But it also opens up the ability to sort of check ourselves between two leading visual programming languages to see what is the actual most efficient result. So in this example here, I'm going to talk about Galapagos, where I've basically run an evolutionary solver for a volume against surface area analysis. So basically, the larger the volume, the less surface area, and so on. So this is what an evolutionary solver looks like while it's operating inside of Grasshopper. And so what's happening here, it's trying to itemize the best results in the most efficient way for one solution. But in the process, what it's doing, as you can see, as it's coming toward its sort of peak in the graph, it's no longer changing as much. So this would be the best solution based on the problem that I have spit inside of this. But it is showing me all the other sort of possibilities, and I can filter those out down here to the best 10%, or I can see all of them. Over here, I can pick one if I wanted to visually manipulate it myself and see what I like aesthetically. And I think this is where it gets really interesting in terms of the human giving himself the ability to see multiple design options in a span of minutes and then make a decision versus sort of going down a rabbit hole of constantly designing and then redesigning again. Whereas this sort of does the heavy lifting for you, and you can start from an actual beginning point rather than from zero. So that's Galapagos in Rhino. Now let's talk about Galapagos in Revit. So I'm basically running the same exact script, but I'm doing it using Rhino Inside, which you can see up here. Now, what's really, really cool is that it's actually faster inside of Revit, but the Revit kernel is able to handle this, and it is running the same evolutionary solver, but strictly inside of Revit. And once it's done, I'll show you guys the different permutations of how I can pick from them. But essentially, I can bake it in to Revit and use it as a massing, a native massing, well, it's not a family, it's a mass. Let's see. Down here, I'm going to rewind because this is going to take a while. But a couple of things I want to talk about here. One is that you can essentially, if you're unhappy with what you have, you can change it on the dime to another option and then redirect that information back in here. So it is latent, as one would say. And so here I'm going through Grasshopper, and I just baked that massing family inside of Revit after I selected the most efficient sort of design based off of a Galapagos evolutionary solver. Now, another thing that I do want to talk about here is with Galapagos, it is going to go to the one sort of an essential kind of like the best solution. It is up to the user to see if that solution makes sense, design-wise, aesthetic-wise, zoning-wise, shadow study-wise, and energy-wise. And so, whereas with the Revit solver, it gives you all the options, but it does not subject you to the one. It lets you be the guide of what you want to choose in terms of design to problem solve. So this next example is straight up based inside of the generative design function that Revit has to offer. So these are some pre-baked solutions that are already pre-existing inside of this option, whereas the ones that you would sort of make for your project would have to be written in Dynamo and then piped into here to create a study. You could start from the base here and use them or rebuilt on top of them. What I'm doing here is just testing out an idea of 6-foot diameter spacing using, I guess, COVID, current COVID times of thinking about office planning, which I know our team is working hard to create something not as crude as what I'm doing. I'm using the sort of simplified version and testing this out, but I know Clark and company are really doing some awesome stuff with that. Another thing I do want to talk about here is that we as Microdesk offer this service where we could build out, your own custom outcomes based on the type of practice or business that you run. This is going to take a bit of time, but essentially what it's going to arrive to, and what I found out, is there are some glitches and things that need to be checked out. So it's populating the different outcomes based on a spacing from the edge of the walls to the edge of each desk that I want to place, and I made my distance between the X and Y 3 meters, which is a little bigger than 6 feet. But I just wanted to see what kind of solutions we could get. And here I'm just going to go through the filters. However, what I found while testing this was that when you do place it, so you're able to create the elements inside of Revit, for some reason, and I'd probably have to go back into the code of how the Dynamo script was written for this, but it doesn't center it inside of the room. It pushes it, or it offsets it from left to right or west to east. And so these are the tweaks that one would have to go and manually change inside of the Dynamo environment. So basically what just happened there is from that study, I was able to place all the rooms that would fit efficiently inside of this box. So use cases, I can see a lot of things happening down the line from the 4 or 5 examples that I gave. But really what I'm excited about is that you can take conceptual and schematic design and really reduce the time spent on it from sort of, when you're doing a redundant workflow, these kind of tools can just quickly help you get to the actual design process versus you sitting there and redoing the 5 to 7 different options. Now, that doesn't mean that the architect doesn't have the inherent sort of knowledge to sort of project where he wants the project to go. I feel like anything like the pencil, like paper, like trace, this is just another piece of the tool belt that we can use and quickly sort of invigorate our minds in terms of where we see the built environment going. I definitely have seen some great examples in like landscaping where you can do proxy generation. Spelled that wrong. Square footage analysis for sure. I love design based on constraints rather than like subjective genius. I think that sort of friction between design and efficiency and standardization we'll start to see more of. I've seen a lot of bridges and structural diagramming of buildings being done through visual scripting and then run through generative models. Vantage point analysis is another one. I just threw this up here as like the sort of ecosystem of where I can see things going, and I'm obviously missing things like I'm sure on the electrical side I could totally see just placement of all outlets based on a standardized height inside of a room. I want to spend some time here to give you guys a bit of where my thinking is coming from and just share a couple of websites and a couple of really awesome references. I think the first one, which I pulled out, was the Generative Design Primer, which was built by Autodesk. And that is a great starting point to make yourself at home in this new world. So I'm just going to pull this up over here and do a little show and tell of how other people have done it. But as you can see, there are standalone applications that are growing inside the industry. For example, Finch 3D basically does what I was doing with Galapagos, but as its own service. We've got Hyper, which is also a procedural modeling plugin. Envelope for city planning and zoning basically takes what I did with Galapagos, but offers it to a more calibrated real estate environment. Here I'll show you how one of these looks. So essentially, these guys are using a Galapagos plugin strictly inside of Grasshopper with Rhino. I really like, we're trying to work with Plan Finder as a partner. They are able to do the same thing, but with both Revit and Rhino, which I think is a great cross-pollination. HyperR is also really cool. And obviously, Ladybug and Honeybee has now also been incorporated into Revit through Dynamo, so I'm going to check that out next after this study. Another big reference point where a lot of this has come from, and I don't want to play the video, but I highly recommend you check this out. There's a gentleman called Nate Holland that basically built his thesis on the idea of, from beginning to end, strictly designing the building on constraints with no additive sort of aesthetic finish from the design end. So this is a great, and I'll share this presentation when I'm done. And then there's also a great Autodesk solutions page for videos. This one I just saw recently, and like I said, I'll send these all in an email of how to think about the different ways to use it. But I guess I'm going to open it up for questions. I feel like that was short and succinct. Does anybody have a question for me? Got you. Okay, so Luke has a good one. How do you see some of these being reapplied for COVID? Well, obviously the 6-foot diameter is the easy one. I foresee complete changes in just offices, so I don't know if we're going to see the whole open office structure become the standard anymore. I think we're also going to start rethinking, what kind of objects we place in offices as remote work has definitely changed the way that we work inside of this environment. I do see one big one that I foresee happening in the COVID world is how we treat air conditioning and how we treat, placement of air inside of a room, because that seems to be the sort of trigger of how it gets distributed. Okay, one from Damien. How do you see immersive tech adapting generative design? I think immersive tech will make it less scary and more approachable. I definitely see that, because for a long time it's been in the realm of users who know how to script and be parametric, but if one could essentially show those solutions to someone that is not a scripter. And so I think what it will do, it's going to move the design technology and the computational departments into the studio environments. I also see it Are there any connections to CFD via Rhino? Want to study airflow? I can't read your whole sentence, Luke, but hold on. Want to study airflow with the generative process? Yeah, actually, that's a great question, Luke. Luke, you got some awesome questions. Uh, I think that with the Ladybug tools and Honeybee tools, you can actually look at airflow systems inside of Rhino and then bring your findings into Revit. But also, you can use physics engines such as Kangaroo to do similar things as well. I hope that answers your question. Someone was interrupted by a client call, but we will send you the recording. Please send us an email and we'll for sure make this available. I believe the recording is going to be on YouTube at some point on our Microdesk channel. Yeah, I wanted to keep this short and simple because I do have other examples of how to use this, but then they become quite difficult. And I can also, if anyone is interested, I can share my general scripts for what I use to do this so that you can test it out yourself, as they should be available. But as I said before, if you're working on a project environment, please contact us because we're able to provide these services on a more higher project level and save on costs and save on your schematic design problems. Awesome. Does anyone else have any more questions? Coolness. Alrighty. Well, I'm going to call it a wrap. And as I said, we'll be sharing this once it's ready to go and produced. Well, thank you guys so much for attending, and I look forward to doing more of these down the line.